Okay, let's see if this is going to work. I'm one of those rebels who doesn't run OS 10. Thank you very much. That's how you get your audience into it. So I want to go over a little bit about what I'm going to talk about, just so you have a general idea and you can know when to go to sleep and when to wake up. The first kind of thing is that we want to talk about is the problem space that Noah fits into. I know some people are familiar with what Noah does. Some people aren't. A lot of people have come up to me and asked me about it. So this is hopefully the talk you should be at. After that, we're going to talk just a little bit about orchestration, go into the specifics of Noah, and get some use cases. And I really hope I have some time for Q&A. So the first thing you probably want to know is, who's that kid? That's my son. That's how most people are familiar with me. So I always like to put, like Luke said, pictures of kids in slides because they work. All right, first thing I want to talk about is a brief history of time as it relates to configuration management. So in the beginning, we did things fairly manually, and this was generally regarded as a bad idea. So we took notes. I don't know how well some of these are going to come up for you guys out here or remotely, so if you can't tell very well, this is a text file that I pulled off of an actual live server that tells you what's installed and where I got the packages from, where my friend got the packages from, and where they happen to live. He actually has the same name as me. I don't know how that happened. That's why he's my friend. This was the beyond the taking notes. We did shit like this. We wrote documents. We handed them out to people, said, this is how you build a server. What's really funny about this is really these two documents are exactly the same except for like some IP addresses. So one was for our Atlanta data center and one was for our corporate office for setting up Tivoli Storage Manager. So then we got creative. We started writing shell scripts. Whoopsie. And this is, again, one of my friend's shell scripts for upgrading PHP on his server. What's really interesting about this shell script is it pretty much doesn't work. So there's a lot of bugs. That's one of the problems with shell scripts, fragility. Then we got smart. We got CF Engine. We got Chef. We got Puppet. And the world was a better place. So like they say, we started evolving. We went from the low level, higher order languages type stuff, and we got smart, and we started doing things that developers did. We treat our infrastructure as code. And generally, the world was a better place. So if it's green, ship it. So we've got this problem knocked out, right? So, sorry, the mouse is a little jumpy. This is a quote that someone made, my friend. And basically, my friend said that at this point, configuration management is pretty much a solved problem. And this was a pretty big revelation to people. And people were really excited about it. And the response was generally supportive, especially by important people like Andrew Clay Schaefer. He was totally behind this. So we refined the idea, and what I was really trying to say when I made that statement is that at some point in a tool's life cycle, or the concept of a tool, let's take configuration management. We get to the point where the tool does enough for now. And beyond that point, we start saying, okay, we've got this solved up to a point. What else can we do? What are the new problems that we're seeing? What doesn't work for us? And does this tool solve it? Or maybe we need a new class of tool, or maybe it should be a part of this, but we don't know what that point is yet. And the question that I keep coming to, and the one that other people have talked to me about, and I see questions on mailing lists and things like that, is how do we think beyond where this single node where we're doing the configuration management? So that's really what the heart of what Noah does is, at least as the itch that I wrote it to scratch. So really, again, two things that Noah's attempting to do. So you'll notice I have the word orchestration up top, and I know Luke was talking this morning about the M-collective orchestration stuff, and he was referring to a more command and control kind of thing, whereas in my mind, there's a little bit more to orchestration than just command and control. There's a bigger component to it. So really what Noah's attempting to do is bridge this, there's this impedance mismatch between developers and operations and the domains they control. Yes, we have Puppet managing our systems. The developers don't, in the sense that, it's very infrequent that developers are managing the configuration of an application inside of Puppet as manifest or whatever. So you've got this use case, this problem that has always come up with me is, who controls these settings? How do we to manage a change? So that's sort of especially if you write your own applications in-house, so that's this impedance mismatch I'm talking about. And then the second thing is providing a mechanism for coordination between all these applications, the nodes, the services, configuration management, all these things. It's a pretty grand vision, and that's really what I'm looking at when I started working on Noah. So before we get into the nitty-gritty, I want to give you kind of an example use case about the kind of place where Noah works. So if you're thinking about elasticity, and how many folks are, at least here, running on EC2 or something that's fairly elastic, where you can provision capacity on demand pretty easily? Okay, a few people. Our company is entirely on EC2. And so in our case, we're driving towards a fully automated capacity scaling situation. So if we need more capacity, it's automatically provisioned, taken down afterwards. So in this case, if we were to model that need with Noah in the environment, we might have a situation where Nagios, as much as monitoring sucks, have Nagios tell Noah, hey, capacity's reached. At that point, Noah informs our provisioning system, whatever it is. Maybe it's Knife, maybe it's something custom. But at some point, your provisioning system kicks off a new box. When that box or capacity is allocated, you tell Noah, maybe it's an app server, so it needs to go out and do a Puppet run on your load balancer. So trigger that, trigger Nagios to do a Puppet run to get the updated Nagios configs. That's the kind of thing that I see as orchestration, the kind of thing I'm trying to address with Noah, and it coming from an operations perspective, since that's my background. So Noah is kind of a play on the name Zookeeper. It's inspired by Apache Zookeeper, which is a project that came out of the Hadoop group kind of thing. It's now its own thing. It was, if you look at the definition, this is provided by the Apache group, which is why it's so wordy. But it essentially says, Zookeeper, well, you can read it. It does a lot of things, but it basically is saying, you've got shit here, applications do this thing, you've got all this stuff, and we provide ways for you to coordinate interactions between them. So it's got these cool features. We've got this, the main object in Zookeeper is called a Z node, and it's similar to a Unix file system hierarchy, /servers, /production, /blah. We've got that there. It does leader election, locking, configuration, sequences. Basically, you can say, at this path, I want this to be a distributed lock. I want all of my applications to talk to Zookeeper, go to this path, get this information, and only one node can do something at a time, so I want Zookeeper to be the lock manager for that. DLMs are really hard, and Zookeeper does it. Sequences, as a node connects to Zookeeper, you can have a Z node increment itself. So it's got all these cool features. Zookeeper itself is distributed and highly available. You see a lot of cool, how many people are familiar with the Storm thing that Twitter just released that came out of Backtype? That's essentially using Zookeeper at the back end. You see a lot of projects now where people are using Zookeeper because it solves this space. It's sort of the next problem space that we're seeing. Like I said, for application developers, it does something very good. But it has And also it has watches, and I'm gonna get into watches quite a bit in a minute. Watches are really cool, and I really like watches. Not these. Downsides, persistent connections. So again, I said we're hosted on Amazon EC2. We might have services in the future on other cloud providers. I can't do persistent connections. I can't centralize that and do persistent connections. The official bindings are in C and Java. That's great if you write your apps in C or Java. If you don't, you're kind of screwed. So from the C perspective, it's not as bad because a lot of the libraries, like the Ruby library, I think the Python library as well, leverage Zookeeper's C library and do kind of a FFI, foreign function, like a binding kind of thing there. In Java, it's really easy. But the other thing is Zookeeper, because again, this is not necessarily a negative against it, it's just sort of a downside, is that because of all the stuff it does really, really well, it's kind of complex to set up and run when you really start getting into multiple Zookeeper servers and positions of log files and disk and how to really make it redundant and how much you rely on it. So one thing that we've learned is people are willing to accept, in a sense, a lesser, I don't know the best word for it, but look at how many people run on Amazon. They put up with a lot of shit, but they still stay on Amazon. We're one of them. Amazon has all these outages, but one thing that Amazon has taught us is, I think, as a infrastructure provider, is that it really has brought the concept of things failing. So people tolerate a little bit less of this, nothing's gonna fail, right? Or we highly distribute it kind of thing. But so here's the thing. With Zookeeper, I've always needed something like Zookeeper. The problem is I've never had the luxury of all the stuff that it can do, or that it needs, the additional features, the language bindings, the stuff like that. So what I said was pulling a, Ron Moore Battlestar Galactica kind of thing. Let me reimagine this. So I looked at it and said, what do I really like? Well, if you go back here, I said I like the Z nodes and I like the watches. Those are cool. We can all handle file system. That's a concept we get. We can work with it. And the problem is, again, if we go back to those other issues, I want to make it use something that I am comfortable with, that I can use from any language with the base libraries that the languages come with. Every library comes with every programming language has a native HTTP parsing kind of library, HTTP client, essentially. JSON is pretty standard unless you're using Ruby 1.8. So that was the model I had in mind, is this HTTP and JSON are, for better or worse, they're the language of the web right now. For web services and this model and REST, despite whether it's official REST or not, these are the things that people are using. It's simple, it's something we grok, and it's something we can use from pretty much every single language that we have right now. So the interesting thing about this talk is that part of it needs to go over a little bit about how to use Noah before we can understand better some of the use cases. So I'm going to go through some of the basics about Noah. Much of this content is on actually all this content is on the wiki on GitHub for Noah, and there will be links at the end. But it's a little bit different format for this, but it's similarly the same thing. So Noah has this concept of primitives, and it works a lot like primitives in a programming language. What are the base objects or the base types in your system? In Noah's world, we work with these primitives, and these are, at least, these are personal opinions as to what we would consider primitives in an operations or an infrastructure kind of world. We have hosts. We have services, applications, and configurations. You can see that host and services smells a lot like Nagios. That's because, again, Nagios is something that I took a little bit of inspiration from in that regard. It's a model that we already understand. If you look at applications and configurations, these are a little bit more lax. The best way to look at these is hosts are essentially your servers, your nodes, the physical or the virtual machine or the instance, whatever. A service is the traditional what's listening on a port. Is port 80 open, 8080 kind of thing. Applications are next up the stack. So we've learned from Nagios and from monitoring in general that we can't just tell if port 8080 is listening. We need to know if our app's running in the container. It's great Apache's up and listening, but where's my app? That's kind of how you want to conceptually think about the difference between hosts and applications. Configurations are just chunks of things that bind to an application. So an HTTPD config, a server.xml, a database.yaml, those kind of things can belong to an application. The strict requirement on these primitives is that there are, again, a set of rules that you have to follow to use the primitives. There's a couple other options in a minute I'll get to if this doesn't fit your worldview, which is fine by me. With the host and services, you've got to provide a status. Side note, Noah doesn't manage this status. Again, if you remember from the use case, the idea is that something externally modifies the data in Noah. So these are more to get you thinking conceptually about how you can model things into Noah. Services have to belong to a host. You can't just have a service called HTTPD. It's got to belong because it's a compound kind of indexy thing, key with a host. Applications, they're really nothing more than just the name. However, you can assign any number of configurations to an application, and the configurations don't even have to be bound to an application. They're just chunks of data, but it made sense conceptually that we might have a config file that worked for multiple applications. It's a common config or something like that. Then we have the not-so-primitives. Sounds like a great band name, actually. So ephemerals. The ephemerals are traditionally or conceptually almost exactly what you get in Zookeeper. It is an arbitrary path with some data at the end of it. I don't care what the data is. There's a size limit. I think I don't remember off the top of my head what it is currently, but I'm going to make it tunable, so it doesn't matter. But essentially, it is slash something 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 has data here. There's not even a correlation between higher elements in the path and lower elements. It's really the key is the path name. So, but the flexibility there is that you can arbitrarily define how you want your information stored in Noah. We have tags, and I don't think anybody doesn't know what tagging is. We do it all the time on Facebook and things like that. But it's essentially, again, a tag, some sort of grouping for these things. It can consist of any primitive or ephemeral. It doesn't matter. You can define it as many you want, apply a tag to as many as you want. Links are, I'm going to get to them in a little bit in more detail, but links allow you to create custom namespaces in the system. So every path in Noah, and we'll have a slide coming up about that, but every path in Noah is prefixed with the type of primitive or ephemerals. So, but that may be a bit kludgy or a bit wordy. So links are in development, but the purpose of links are that the root URL will be some custom namespace you've created, and everything that you do happens off of there. It's an attempt to provide some sort of multi-tenancy in the system. And then, again, watches. Watches are really cool. I like watches. You'll hear that quite a bit. So the URLs, you can see here, hosts, it's just /host, some key, which is the host name. If you want to go further, you can append services /service name. Any one of these paths can be chopped off at any point. So if you go to the root of the slash on Noah, you get a sample page with a list of some sample links that you can click on. As you go further down, though, you can get all your hosts. You can get one host. You can get all the services for that host. You can get one specific service for that host. So services work the same way. You just kind of flip it around because of the binding. The URLs look similar. Applications, again, the name, the configurations associated with the log level. What I want you to see here is the point of these paths is to be as programmatically friendly as possible. I want you to be able to just chunk a variable in there somewhere and be able to template how you get this information. That's really the goal there. And all of these paths, the majority of these paths, there's certain points that it doesn't work. They operate with standard HTTP verbs. You can do a curl script and send a put, delete, get, and you'll have certain things happen in the system, and we're going to go over that. Woo-wee. So getting the data. This is a standard response from Noah. This is, to me, this is beautiful because it's JSON, and I like JSON. I've highlighted a couple of sections here to identify these. The 1, 2, 3, 4, 5 sections that are highlighted are going to be pretty common. They're common on every single request you make. And it's just a set of timestamps, any tags applied, an ID, which you probably won't ever need to use because you refer to everything by the friendly name that you've given it, and the links. And in this case, there are no links or tags in this for this specific example. So hosts, this is these calls that we're going to be showing on the get are to the root levels of each data type, so host, services, things like that. So you'll see multiple data types or multiple entries, just not completely documented. So if you get all the hosts in the system, you might have, again, the first entry, the key foo. Down here, you've got the services that are associated with that entry. And if you look down here, you'll also see bar. That's just that entry happens to be for screen size sake, empty there. Services, again, not much different. It's for services, again, because of the binding with host, we've just flipped around a little bit. So here, there's a foo service in the system. It's got host foo. There'd be another entry, then down below, there's another service entry for bar. There's, if you'll see here, there's the host name that's bound to it. So applications, these are pretty simple. Again, the first key is the one that you referred to by the URL, so that you know the entry. What's interesting down here is we have this particular application entry, though it doesn't require it, has configurations associated with it. So this has a database.yaml, and there's the body of it, and we're going to come in here and show the configurations in a little bit more detail. So this is just, again, random entry in the system. What I want to point out about configurations here is there's a format and a body, and we'll get into what those are in just a sec, but I want you to take note of that because that, if you go back here, you'll also notice that we had format YAML and a body of what is essentially escaped YAML. And here it was just a string object, some string value. And ephemerals. There is no JSON for ephemerals. Like I said, ephemerals are arbitrary paths with arbitrary data in them. I don't even try to interpret it. You're going to get back essentially whatever you dump in there. If you dump binary, you're probably going to get it back. I don't think the system handles it very well, but the idea is that you use ephemerals for some custom pathing kind of thing. You don't actually have to put, what's interesting is you don't have to put any data at an ephemeral path. You can just leave it blank. You can just make it an existence kind of thing. Is it there, isn't it? Putting data, I want to put up this little slide about the paths again because puts and deletes have a little bit more restriction on the paths you have to use. So when you put data, and again, deletes have the same restrictions, and it'll come back up again, but it's at the host level, services at the service host level, applications, configurations, and ephemerals are all the way down when you put the data there. This is going back to simplicity and ease of use. This is how simple it is to create a new entry for any one of those types in Noah. This is easier than me managing a persistent connection with some custom Zookeeper protocol, blah, 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 blah. I can do this. I can do this with curl, and I can do it in a shell script. I can do it from my application can do this. I can do this in an init script, for God's sake. That's pretty cool. If you're using init, which I don't know if many people are. Again, host, just the path is, /host, the name, just send that payload. Same thing goes for service. Service has an extra field there, a little bit extra work, and that's because, again, there's the binding between a service having to belong to a host. So if you create a new service and the host doesn't exist, it will create it for you. and that's why you have to provide a status, host status, is because it needs to know what status to give to that entry if it doesn't exist. Applications is there's a name, configuration, format, and body, and ephemerals, raw data. Okay, back to the deleting data. There's, again, it's the same kind of path system that I mentioned, and there is no payload for deleting data. Just make a delete call, and it's gone. So tagging. One of the things I really, again, back to the simplicity thing, pretty much any path, back to the basic object path that you saw, you can put /tag at the end and send that payload, and it'll have that tag now. If you want to get rid of that tag, you send the same payload with whatever and delete it. You can get a specific tag at /tag tag name or get all the tags if you want to. Linking is similar to tags. I said I'd go over this. So the idea is that you will put, if you apply a link to something, on any number of objects, you go to the NOAA server, :port / that link name, and you get a subset representation of NOAA as a whole. You still get /application / but it's restricted to just yours. That will allow in the future for multi-tenancy kind of situations if it makes sense to restrict access. And again, same concept, delete instead of put, /link name. And it's, again, custom namespaces. So watches, I said I liked watches, and I'm gonna go over a little bit here. Zookeeper watches are different than NOAA watches. First of all, they are ephemeral themselves. They go away. When a watch is fired in Zookeeper, when you register a watch, once it's fired, you have to register it again. That creates a small race condition. Let's say it's something that's the equivalent of a Nagios flapping kind of situation. When you create a new watch, if something is happening very rapidly, you may miss another event because you are still busy creating the new watch. So by virtue of how NOAA is designed as a stateless kind of application in that regard, we keep watches persistent. The main reason is that the watches are disconnected from the people who are using NOAA kind of situation. There's that's going to change a little bit. There's going to be an expiry ability added when you create a watch as an optional kind of thing. It's pluggable. It uses a URI-based kind of scheme, and everybody's familiar with URIs. So it's something that somebody can easily understand. It can easily be broken apart and determine components of where to send a watch to. It's hierarchical in the sense that it has supersets and subset restrictions. So if I add a watch to /applications, so that means anytime something changes in /applications, I'm going to fire a watch to the endpoint, which is who is the concerned party, essentially, every time a change happens. If I were to allow registration of another watch for that same endpoint under /application /my app, he would get notified twice. That could cause a whole bunch of crazy shit that nobody wants to happen. So what the restrictions are is there's a superset and a subset rule, which basically says if you've got a higher precedent watch in place, you can't create one below it, and vice versa. If you have a lower precedent, you can't create one above it. The goal is really just to prevent duplicate messages getting sent to the same endpoint. The restriction is by endpoint. You could still add another endpoint that gets all the applications versus one that just wants to know about its own. So really the only requirement there is that you delete the existing watch and re-add it. Like with tags and links, if you want to add a watch to an object, just add /watch at the end and send a payload of endpoint, the URI for the plugin that you want to use. There's also a /watch top level that gives you all the watches, and you can create arbitrary patterns that NOAA will identify and match against at that one. It won't be bound to a specific one. So in this case, at that endpoint there, the first example might be sent to /applications my app, whereas this one says this one says applications app name, whereas the other might be all applications. So it just gives you little bit different entry into the system, but if one of the /watch options doesn't work for you because it's not precise enough or it doesn't allow it at that level, you can do it through this /watch at the root level. So now we're going to get into some of the how to use it. Again, I said I want to be able to use this from anywhere in the world or from any system. This is a curl script that is going to create a watch in Noah. Again, you can actually pre-create watches outside of any existence of an object because it's the nature of the asynchronous aspect of it and the stateless aspect and the disconnected aspect that we can't really put those restrictions in place. So if you look here, we're going to create a watch on all applications, and when there's a change under applications, we're going to send an HTTP post to host ping. So we've done that. We've created the watch. Now we're going to perform just a standard operation. We're adding a new application called foo_app. When we add this, this is what host/ping gets in the post. The current state of any changes under that path. We created a host. It got the entry, and you can see there's the action was created. There's the standard ID, tags, links, timestamp stuff that's in all the others. If there were any configurations associated with it, you would get those as they were added. And then you also get the pub category is more for my benefit, but it can be useful to you if you want to know how it was matched. Well, this is exactly, if you want to maybe reference this in the future. So if you got one for all applications and you had a bunch of them come in, you want to start filtering them down, you could see how they were seen in the system by using the pub category. And so now we're going to go in and, again, we're going to use curl and take that application we just created and add foo tag to it. And again, it's just /tag with a very simple payload. Another message is sent to that ping endpoint. So you can see now we've changed. It's got the tags in the tag object. The name is, again, the same path. The action has changed. So you can actually filter on, when you receive these messages, it's very easy to filter what happened. This is what was created, the path in the system. It was either created, deleted, or updated. You have to do some management on your side about what the state change was between the two. But a lot of times you'll find yourself, at least as we use it internally, these are one-off signal type situations. We actually, in several cases, ignore the payload. We just want to know, we create a specific watch just so that this guy gets pinged somehow when something changes. So like I said, watches are plugin based. I should warn you that all those pretty URIs you see there, they don't actually exist. It's plugin based. I'm giving you examples and encouragement to write these. But you could do this as your endpoint, an AMQP, dump on some exchange. You could optionally in your AMQP plugin, I actually will probably be writing this very soon, take that pub category and make that the routing key for your exchange. So when you put the message on there, you could do some fancy work with that. Rundeck, I actually have a working Rundeck implementation using at least one, it requires Rundeck 1.3. It's not released yet, but you can tell Rundeck to kick off a job when something changes. Again, the watches, as they're registered in the system, are disconnected from the people who actually get notified. And in this case, the Rundeck plugin that I have written, it's more of a ping thing. It's just more of saying, hey, this has changed. I want to kick off a Rundeck job. And you can specify it as part of the pattern. The third one, I think, will be pretty cool for some people. Maybe you want to trigger a Puppet run when this happens, and I'll explain the general idea behind that in a bit. Stats_D, if you like numbers, it would be really cool if you could say, hey, look, we've just updated a record. Every update, I want to, dump something in Stats_D as maybe as a time marker, or so I can graph something over time. How many hosts have we brought up and down over a time period because we're super elastic, kind of thing. I don't know how many people actually know Ruby, but right now this plugin system is using Event Machine, which is an evented I/O framework kind of thing. I'm moving that to a different pattern using actors and worker pools because it's a bit more flexible, and because you don't have to, if you write your own plugins, you don't have to be sure and be EM safe, which means don't block the reactor, which is a big no-no in Event Machine. So again, All about simple. I want anybody to be able to easily use this. Just some general notes on the watches. The creator of the watch is unrelated to the receiver. I think that's very important, is that when we get to the Puppet integration, Puppet can create an entry in Noah, and Puppet doesn't have to know to tell somebody else when it creates an entry. That bridge actually doesn't exist outside of, say, doing some kind of command and control with collective type stuff and using reports and whatnot. This is nice because you can actually, Puppet can add an entry to Noah, and that entry can trigger something completely unrelated that nobody else, the consumer doesn't need to know about the guy who put it in there. That's what I'm getting at there. You don't have to use the official watch daemon. The backend data store for Noah is Redis. That's not likely to change anytime soon. If you can write something that can talk to Redis, specifically the pub sub functionality of Redis, psub and whatnot, you can write your own watch system. You'll see everything that comes across the system. Every change is published onto that pub sub bus inside of Redis. Again, you can watch the watches if you just want to sit there and go, oh shit, that's cool, all that stuff scrolling by. We like to do that. So let's go over a little bit about, because this is PuppetConf, you probably want to know how this works with Puppet. So James Turnbull did some work for me on his own volition. And he created a set of a module for Puppet called Puppet Noah, strangely enough. It consists of an ENC for Puppet, which is nice because that means your system of record is now also part of your bus, essentially. Some functions and some factor integration. The mappings are that hosts in Noah map to nodes, the services map to the classes, and that's nice. Again, there's the restriction that services have to be bound to host by name, so it gives you some flexibility. And configurations, the configuration objects map to facts using the Noah data fact plugin, but the restriction is it only supports string types right now. Hopefully the factor nested structure thing bug gets worked out eventually at some point, which will be very cool for doing some more hierarchical kind of fact stuff. So James wrote these. Funny little story. I was going to update these as like a big release. I was going to do that tonight because I thought I was talking tomorrow. So that didn't happen. I am going to still work on it tonight and update those. The current version of those does not work with the current version of Noah. That's the only, you can look at them and I will go back and update those tonight and make a pull request if that gets taken care of. So now, let's take a big breath here. That was a lot to go over, but I think it was needed to understand where we can do these next quick sections here. These are just some simple use cases. Now that we know how Noah works, what it can do, let's go over a couple of building block type scenarios. So Noah, Puppet, and your application. We're talking about your application again. If you, like the Constant Contact guys, they have their own app that they write and deploy. But before we go into specifically how Noah adds to that, let's look at some of, taking Noah out of the mix, what's a traditional workflow management with your applications and Puppet. So Puppet knows about your nodes and your classes. Your app may have this configuration file. Maybe it's a Spring properties file or a log for jconfig or, again, database.yaml, any of these things. Optimally, that file is controlled by Puppet, right? I mean, that's what we want, is that we want to manage consistent configuration. The problem is that to make that change happen, you essentially have to do a new run on the nodes. There's a couple of issues with that in general, that model, and these are personal things that I've run into over the last, however long I've been using Puppet and other tools in the configuration management space and in general. The Puppet repo, where we store that code, is not the app repo. I heard the Constant Contact guys saying they have a solution for that, where they keep where's the code locality for that. But in general, that's two different repos, and it's a pain in the ass to manage both of them, especially if you're on the development side of things. Your devs, I say must, but they may have to learn ERB, and that may not be their comfort zone. This is a problem that we ran into. It's like, okay, well, here's how you use this. Here's your configuration file, and you have to template it and put this here. No, it's ERB, and here's the name that we want to, that never mind. Maybe you then just say, you know what, learn Puppet. That may not go over. It may go over well. I think that it is very valuable for your development team to understand the configuration management tool, but it's not always possible. Luke was talking about rampinosity or rampiness? Rampination. Burnination. The rampination thing, it's the same kind of thing. You have to take these baby steps to get to the point where everybody's operating on the same page. What about when we add new settings? The problem I've always run into is someone didn't make a communication. Again, some of this is soft skills, but I think that a lot of soft issues can be solved with some very basic technical tools. We forgot to add this setting and tell you about it, and now you got to go back and make sure it's in, you're passing it to the template, and it's a pain in the ass. This is one I'm going to go around in general afterwards and ask people because I'm very curious. I have yet to go in a shop where we run, whether it's Chef client or our Puppet client in daemon mode or via cron. I don't know how many people do it, whether you're at that point, but that's that fully automation point. And that's a ways away for a lot of people. So that's, to me, at least in my experience, that's the exception rather than the rule. So if we throw Noah in the mix, now Noah knows about your nodes and classes. We move the volatile settings into Noah, and I'm going to talk about volatility in a minute. Configuration file is still controlled by Puppet. It still is built by Puppet as like this is what we want it to be. This is the one true configuration file. However, your app gets some of the volatile settings from Noah. Future Puppet runs will update Noah when some things change. Noah can tell your application. We're getting into the concept of truth versus reality. When I go back to the configuration file controlled by Puppet, Puppet should always have the true version, which is my DB master is this guy. But right now, that box is gone because we're rebuilding it for whatever reason, or maybe we just decommissioned it and we haven't updated. For any number of reasons. Right now, this is my DB master. That's reality. Truth is managed by Puppet. Noah manages reality. Volatile settings. There was some statements made this morning I kind of disagree with, but not all configuration is created equally. We frequently need to change our log levels on the fly. JMX exists, and people are taking advantage of it, whether you know it or not. Elasticity. We scale up, we scale down based on capacity demands. The state of the environment is not the same, so knowing who all of the foo nodes are at a given time is very important because it's not the same ones it was created with. You may have a base of these 5 foo nodes, but we may be running 20 right now because it's a peak period for us. Ad hoc configuration, like I said, logging levels, and your environment, your applications have settings that need to be environment aware, and it's better managed outside. So what are some of the benefits of that setup? Don't have to learn ERB. Developers are comfortable with JSON and HTTP. If they don't, I want to talk to them. They don't have to learn Puppet. Again, whether or not you think they should, we're talking about ramps here. It's an ops and development friendly bridge point. That's really the crux of that. Bridge point. That here's a place that we can come together and bring each person into each other's world, essentially. Again, no unintended changes released. I've been in situations where we made a commit to our Puppet repo, but we had to make a run for some other reason, and something that wasn't, either shouldn't have been committed, again, soft skill issue, it went out. So this kind of helps prevent that because it doesn't require a Puppet run to make that happen. I hope everybody is familiar with the term CI. It was mentioned earlier with your continuous integration environment, your testing tool, Jenkins, things like that. This is kind of a quick, these next few slides are much quicker than that one. How you can integrate Noah into this. And this is a model that we're actually using at Vertical Acuity right now. Jenkins actually looks up a list of nodes for deploying code from Noah via a bash shell step in Jenkins. It's curl. I can do that. Jenkins will, we don't do this, the Puppet triggering part, but Jenkins can trigger deploys on those nodes because it now pulled a list of those nodes from Noah just as part of the regular operation of that particular Jenkins job. Jenkins is always current. You don't have to go in and manage Jenkins' list of SSH keys or Jenkins' list of nodes to deploy to, things like that. It's always current because it's pulling it from Noah, which happens to be the source of your system of record for Puppet. Monitoring. Some people may know, I think monitoring sucks. It's kind of a personal crusade of mine. This particular building block here uses Nagios is based on the one we showed earlier, but essentially that Puppet manages your Nagios configs. Nagios updates Noah statuses in your host and services with an event handler. Again, it can just be a curl call if you want it to be your event handler. It doesn't matter because it's a very simple interface. Optionally, watches would be fired by Noah if you had watches registered. Those endpoints could be inside your application. Work with your developers and say, hey, just expose this path, that says when you get this, do something, and the application will immediately know that, hey, some node I'm working with is down or something has changed, and it can reconfigure itself, kind of like a cool little transformer action going on. Shell script integration. Obviously, this is kind of a not as pretty and cool as the other integration, but this is a problem. We've all had to deal with shell script running on node 1, can't run at the same time as node 2, can't run at the same time as node 3. They all are dependent, and we go out and spend a shitload of money for some fancy job scheduling, processing, batch, blah, blah, blah tool. Go to GitHub. I got this solved for you. Locking and coordination of cron jobs. I have done over the past, I know everybody has done this. Let me write that dot file. If it's there, I'm not going to run. Move that outside the box. You can watch that dot file from other boxes. You can use that. You can use that dot file, the equivalent Noah, to trigger another box. Is that record there? Good. We're going to hold off on the cron job until it's gone. Stop dealing with writing files on the host that you have to clean up, whatever, blah, blah, blah. The trick to this is just using ephemerals and curl. Remember I said ephemerals don't have to have data. You can just store, you can create an ephemeral, an arbitrary path. It can be a binary situation. Is it there, is it not there? So if it's a 404, we wait. When it becomes a 200 and we get a result, we continue. So now that I've made you think that Noah is the greatest thing on earth, and or the seas or the boats, there's a couple of gotchas here. Noah itself is not distributed. Like I said, if you need distributed, there are solutions for you. If you need that level of availability and with Noah, there are solutions for you. And other solutions, and I've mentioned those, Zookeeper is one of those. The redundancy is based on Redis. Right now, the way you make Noah redundant is you add multiple Noah front ends. It's just a Sinatra app that talks to Redis, and you use Redis's native features for managing availability, master slave, possibly the new Redis cluster that's coming out in the next release, or next few releases from now. There are no ACLs. That may be a killer for some folks. It's very high on my priority list. It won't get a 1.0 tag until I get ACLs in place. So that's very important. I mean, you don't want, again, what you've basically now said is anybody can trigger any action in my infrastructure. You probably want to protect that somehow. It's also asynchronous. If you need immediate, like this has to happen RFN, then Noah's probably not the tool for you in that regard. So what are some other options? Zookeeper, I mentioned. Doozer is a project that came out of Heroku, which is essentially a version of Zookeeper in Go, the programming language Go. You can look at a simple NoSQL store that supports, any kind of data on the key value store on the value side that works over HTTP. You could conceivably not even need all the stuff that Noah has and the restrictions that come along with it or whatnot. You can just use WebDis and Redis together and get the same thing. It provides a web service on top of Redis. Nasoy is one that was created by a guy who asked me, I spent a very long email conversation talking about Noah and whether it would fit his use case. It didn't. He's in a largely Python shop, actually all Python. Ruby stood out like a sore thumb. And it had he had a little bit higher availability requirements. So he wrote his own, this is very new, but it's written in Python. It's a simple memory-based key value store, and it mimics Cassandra's Dynamo type stuff on top of that. Or not Dynamo, but the consistency model on top of that. And you can write your own. This is, again, like I said, grab one of those, use React. I love React. It might be overkill, but a single node of React will do, you can make HTTP posts and you can get JSON. The restrictions on this is that Zookeeper and Doozer require persistent connections. That may be out for you. The other options don't have watches. For me, watches are a big thing. So I may have gone over a little bit, but that's it. Does anybody have any questions? I can't see very well, so might have to speak up and yell. Nope. Alrighty. Where can you find it? GitHub. There's an IRC channel right now. It gets commit messages, and that's it. But I'm in there. I'm also on a bunch of other channels, so it doesn't matter. And these are my old and new blog addresses. I just haven't set up a proper redirect. Specifically with stuff about Noah. I've written quite a bit about it at this point. This is me on the Twitters, on the GitHubs, on IRC, where all three I'm typically bitching about Maven most of the time. So if you want to be my friend on LinkedIn, that's cool too, and more blog stuff. So thanks a lot, guys. Appreciate it.